Good morning students. Today we are going to see the topic impulse. If a very large force acts on an object for a very short duration, then the force is called impulsive force or impulse. According to Newton's second law of motion, the force F acts on an object in a very short interval of time del t. Therefore, we write the equation F into dt is equal to dp. Integrating this equation, the initial time t of I and final time t of f. Therefore, integrating this equation, d of b, initial I, final value f, equal to integral of f into dt, initial time value t of I, final value t of f. Therefore, integrating this value, therefore this equation become b, applying the limit value I into f into integration t of I, t of f, f into dt. We are applying the limit value, first upper limit value minus of lower limit value. Therefore, p of f minus p of I equal to integral of t of I, t of f into dt. P of I is the initial momentum of the object in a time ti. P of is the final momentum of the object at a time t of f. Therefore, initial P of f minus P of I. Therefore, P of f minus P of I is equal to change in momentum del P. Then T of f minus T of y. Change in time interval taken as del t. Therefore, the integral f into dt is called j. Therefore, impulse. Therefore, t of I, t of f into f into dt is called j. J is called the impulse and is equal to change in momentum of the object. If the force is a constant, therefore integrate this equation. Therefore, force is a constant taken in the outside. Therefore, integral of t of I, t of f into dt. Therefore, integrating this equation, therefore f into t, limit value t of I, t of f. We are applying the upper limit minus of lower limit. Therefore, this equation become t of f minus t of I. Therefore, f into, we know that t of f minus t of is change in time interval. Therefore, f into del t. We already find the value of P of f minus P of I is equal to del P. Therefore, now this equation del P is equal to f into del T. This equation is called impulse momentum equation. Phi is a constant force. The impulse denote the J is equal to f into del T. That change in momentum, change in time interval, force is a constant, and also is equal to change in momentum del P of the object over the time interval del T. Impulse is a vector quantity. The unit force is a Newton, time interval second. Upon therefore, the unit of impulse is Newton second. The unit is Newton second. The average force act on the object. Therefore, the average force act on the object. This equation become F average is equal to del P by del T. This equation, the average force act on the object is greater. Average force act on the object are greater. The time interval is smaller. Whenever the momentum of the body change very quickly, the force become larger. The impulse can also be written in terms of the average force. Del P is change in momentum of the object and is equal to impulse. Therefore, impulse is equal to F average into del T. The graphical representation of a constant force impulse is given. It is a constant force, so we directly using the formula. Therefore, impulse J is equal to F into del T. The another graphical representation of variable force impulse is given. This is a variable force, so we cannot using direct formula. Integrate the equation. Therefore, this equation is J is equal to integral of f into del t, limit value ti into tf. The next one, illustration of impulse. When a cricket player catches the ball, he pulls his hand gradually in the direction of the ball's motion. Why? If he stops his hand soon after catching the ball comes to rest very quickly. It means that the momentum of the ball is brought to rest very quickly, so the average force acting on the body will be very large. Due to this large average force, the hand will get hurt. To avoid getting hurt, the player brings the ball to rest slowly. The next one, when a car meets with an accident, its momentum reduced drastically in a very short time. This is a very dangerous for the passenger inside the car since they will experience a large force. To prevent this fatal shock, cars are designed with airbag in such a way that when the car meets with an accident, the momentum of the passenger will reduce slowly so that the average force acting on them will be smaller. The next one, the shock absorber in the two-wheeler play the same role as a airbag in the car. When there is a pump on the road, a sudden force is transferred to the vehicle. The shock absorber prolongs the period of transfer of force on the body of the rider. A vehicle without shock absorber will harm of the body due to this reason. Jumping on a concrete cemented floor is more dangerous than jumping on the sand. Sand brings the body to rest slowly than the concrete floor, so that the average force experience of the body will be lesser.